Online. All right. I say yes. Very good. Rich is having technical troubles and he's going to go away, but we hope he comes back. He's on here as host. So I'm puzzled, Rich, if you're on here twice. Okay. Anyway. Hi, I'm Ted Klein. Hi, folks. I'm Ted Klein. Let's start this meeting. We're here on January all the way up to 4, I think, um, of a new year. Happy New Year, everybody. Glad you all came. Let's find out what you're doing. Typically, what we do is start off way off to the east of the U.S. Because it's late out that way. And so we're going to start off with Dimitri, please. Dimitri, what are you up to now?
Uh, Hello all. I have not too much for now. Uh, just tell uh, what is what was failed in last time 2 weeks ago. My my presentations. I uh, just repeat it. Just a moment. Sorry again for connection problems 2 weeks ago. Now I will repeat I what I want to say. Uh, 2 weeks ago, uh, uh, this is about updates of my observations of uh, uh, evolved stars with main lines, some update in my table of observed stars. This uh, just a reminder, just remind this is evolved stars. It can be hydroxyl infrared stars, AGB stars, and post AGB stars with protoplanetary nebula. Also, I observed uh, uh, red supergiants and yellow hypergiants. They are somewhat higher in this diagram at post-AGB, and AGB star is here on Hertzsprung-Russell diagram. Usually these stars are surrounded by dense shells of dust and gas, and this envelope emits in radio waves or hydroxyl 1612 megahertz line dominating, and sometimes weaker lines can be observed in 60-65 megahertz and 60-67 megahertz. Uh, Observations in instrument observations green bank dish 20 meter 20-meter dish green bank beam about 0.6 degree in hydroxyl lines. Uh, some refreshments, some updates in my list of uh, uh, stars with main lines. At least one U star, IRS 18460 minus 0151.
Sorry,
This is
Dimitri, your
yes, yes.
your slides aren't changing. I'm sorry.
Changing. What does it mean changing? Do you see my slide with table?
I only the first one. They're not progressing.
Uh,
Just your title, Evolve Stars with Main Lines is the only one that's showing up.
I'm sorry, we see the little
no,
pictures of your slides on the left. We need to change mode. You may have to actually unshare and then come back on a different window.
okay, okay. Just a moment.
Thank you, Adrian. Good catch.
Do you see the screen now?
Now we see something nice and big with blue near the top. Observer stars with main lines.
Okay, okay, okay.
Thank you.
Uh, uh, if you didn't see previous slides, this is good instrument green bank dish, 20 meter, 0.6 beam width in hydroxyl lines, and table of my observed stars. You can see at least one eight positions new stars. IRS 18416 minus 0151. This stars is strong in 1612 megahertz line and observed line in 6065 megahertz. This is obtained spectra for the stars. 1612 megahertz line is rather strong, double peak spectrum, higher than 100 kilometer per second, and a little deeper of absorption line, because the stars is observed over the background of W43 star forming region. And next spectrum, 1665 megahertz. Also, you can see double peak profile for the stars. And deeper absorption line in 60-65 megahertz. No emission from the stars observed in 60-67 megahertz. About variability, this is interesting. This is interesting to observe variability of stars in main lines, because main lines can work as more sensitive tracers of state of stars and its envelope. Behavior of these main lines indicates about the details of hydroxyl excitations in the star envelope, role of collisional processes of excitations and de-excitations of main lines and a lot depends of envelope density or massless rate. Clear example of this is previously observed 60-67 megahertz line of IRS 17004 minus 4190. Previously observed strong line in 60-12 megahertz, and I observed it, this line too. Previously observed dominating line 60-12 megahertz, strong dominating line, and observed 60-67 megahertz line. Double peak 60-67, but I didn't. I have not detected recently 60-67 megahertz line, and there was rather strong previously up to 10 Jansky, but I didn't observe this line. This tells about that it will be very interesting to observe variability of the star in main lines, and especially in 60-67. So summary: new stars in my list. Observations were made over background of W43 star forming regions. The line 60-65 megahertz have same shape, same profile as 60-12 megahertz line. This is first case. So in my observations, I think this is really rare case when 60-65 megahertz lines replicate replicate the shape of dominating line, and this star can be very interesting for observations in variability, especially in variability of 60-65 megahertz light shape. And surely from previous slides, the stars that in which 60-67 megahertz line detected in 90s, but recently I have not detected this line. It's very interesting to observe variability, at least for these two stars. That's all for now. If some questions, I will be glad to answer.
Thank you, Dimitri. Any questions for Dimitri here?
Please again.
Very good. I don't hear any questions. Dimitri, thank you for your presentation. It's always complete, and you're pioneering new methods. This is great. Thank you.
Thank you, Ted. Thank you.
Rich, are you back? Maybe not. Okay. We continue on with folks far away and suffering time zones. Now wait. Robert, there you are. Robert, tell us what's going on in your world, please.
Hello, everybody, and Happy New Year. Oh, listen to that echo. I feel like Elvis Presley at a recording studio.
Well, we don't hear an echo, but tell us where you are today. Where are you
I'm
are
back
in the world?
I'm back in Sydney.
Sydney, Australia.
And
Great.
Sydney, Australia, and a couple of weeks from now, I'll be off to Mauritius for a partial solar eclipse. It's an annular solar eclipse if I could get to the Antarctic, but I don't think I'm going to make that part of it. Basically, these days I feel like a rabbit. I started doing the analysis of all the scans I made last year, and I said, why are we looking at hydrogen? And I, found this research paper from Oregon, and the number of states that hydrogen takes, is absolutely amazing. And then I find out that, well, the hydrogen atom, has a 1 proton, 1 electron, and the only way we get the hydrogen, the 1.42 gigahertz is, when the hydrogen atom, has these electrons that, well, one spin is with with the nucleus, and the other is with against the spin. And the one that gives us the hydrogen wavelength is when the hydrogen molecule is accelerated, and the hydrogen that spins against the nucleus, gives off the proton. And I go, wow, that's okay. And I said, how do we know that hydrogen's, the most, comprises the largest amount of, space? And I go back to, and there's this report that NASA put out, that, they talk about a couple of femtoseconds, from the Big Bang, and then they go, oh, well, 700,000 years later, it cooled down enough to where hydrogen could start to form elements. And I'm going, well, that sounds okay, but that's just a theory. And then they go, well, maybe the hydrogen was already in the space. And I go, well, that sounds okay. So anyway, rabbit hole. So everywhere I turn, there seems to be it sounds good on the surface, but it takes too long to get there. So basically, the analysis of all the scans have stalled, and nothing's really happened. And in the meantime, we're doing artificial intelligence for robots, working on the observatory, and the list goes on and on. So sorry, I don't have anything, specific to report, but, we're just a work in progress. And again, Happy New Year to everybody.
Well, Happy New Year back. It sounds like you're busy with all sorts of fun things. Yeah, so many fun things to explore. I do agree. If I say that everyone has a list of things to do, I bet all the heads will nod. Yes, indeed. Thank you, Robert. Let me know if I can help with that processing. I have some ways to put them in batch files and things like that. But then we're going to have to get more specific. We can talk by email.
Sounds like a plan.
Going down the list. Eduard, yes, you're off in Europe at this point. Tell us what's going on.
Hello, hello, from the Happy New Year from the Netherlands. Yeah, so over the Christmas break, I've been quite busy, actually very busy with all sorts of radio astronomy projects. I can actually share some slides that I just prepared right now. So let me share this. Oh, this is not the first slide. Already had a sneak preview here. Now we put it in presenting mode. But yeah. All right. Can you see this?
That looks good, nice and big.
Great. Okay. So, well, let's start off with some of the activities with the 1 meter so-called mini maser telescope that you can see over here. So the weather was quite good and stable, so I've been able to do a few observations of quite a few observations actually of water masers. I mainly revisited many water masers that I've observed in the past before. So some of them I try to observe regularly or at least semi-regularly. For example, Westerhout 49, which is the brightest water maser at the moment. That one I'm trying to observe at least every 1 or 2 months. Currently, over the past few weeks, or actually since November, it has been in a sort of outburst state. It has been very bright. So I've been trying to observe it a bit more often. And Wolfgang has also done some observations of this same source. So we are really trying to follow what's going on there. And well, at the moment, it's still very bright. Not many changes since I observed it last time, so I won't really report on that a whole lot today. I did detect a new water maser very recently that I haven't observed before, which is the star forming region Westerhout 31. So more on that in a minute. And what I also did is that I finally solved a pointing accuracy issue that I had with EQMod. So up until now, I've been just using the hand controller, the SynScan hand controller of the HEQ5 mount, which the dish is mounted on, to do the pointing basically. So, and the way this works is that first you align the mount with the celestial pole, and then you need to give it a number of alignment stars so that the mount actually knows where it's looking at. So I have a small finder attached to the side of the dish, and then I point the dish at the moon, for example, carefully adjusting the pointing until I get the maximum amount of moon noise, or sometimes I use the sun, of course. Then I cover the finder with a solar filter, otherwise it would be dangerous. And well, I just basically adjust the pointing until I get the maximum amount of noise, and then I use that to align my finder. And then later on during the night, I can then do the star alignment procedure just as you would do with any regular telescope. This has worked really well, but there's one problem with the regular SynScan device that's attached to the mount, is that in order to do a pointing for an observation, I of course have to be there. So sometimes I want to do an observation of a maser and it's only like up well above the horizon in the middle of the night. And that's very inconvenient because then I have to get out of bed in the middle of the night just to point the telescope to that target. And yeah, I was really thinking about ways to automate this a little bit further. And there was jealously looking at my astrophotography friends who have all this fancy software that they can use to control the mount and to scheduled photography runs. So they can let the telescope slew to or the mount slew to a certain target at a set time. And I was thinking, oh, maybe I can use this as well for radio astronomy. So I was experimenting last summer with the EQ mod program in combination with the NINA program, which is a program that is very often used by astrophotographers for this sort of purpose, to do these to run these schedules. And I was having continuous problems with pointing accuracy. So my pointing was always off by like about half a degree or more. And if you have a beam width of only 1 degree at this 22.2 gigahertz frequency, then half a degree off means that you're already missing like half of your signal. So that's not great. So but recently I managed to solve it. So there is a way to do a star alignment using a planetarium program like Stellarium, and I just figured out how to do this. So I'm quite happy with the pointing accuracy right now. So I still haven't tried the scheduling function of Nina yet, so that's the next thing on the list to try. Anyway, up to the observations. So Westerau 31 is a star-forming region in the Sagittarius region, and at my latitude, 51 degrees north, Sagittarius is very low in the sky. So this source only this source is never more than about 20 degrees above the horizon. That makes it quite difficult to observe because I only have a fairly short window of observation time that I can that I have each day, where the object is not behind some building or tree or other obstacle nearby. And the low elevation also means that you're looking through a lot of air, which means that you're having a large path loss due to the water vapor in the atmosphere. And also the water vapor in the atmosphere also adds a certain amount of noise. And you can also see this over here. So despite all of this, I did manage to detect a very consistent peak at 0 kilometers per second in the LSR reference frame. It was really nice to see that this peak was detected at exactly the same LSR velocity at 3 different days. So that really means that this is an object in outer space and it's not something much closer by, because then it would not be detected at exactly the same LSR velocity over and over again. You can also see a sort of broad hump over on the right of the spectrum at around 15 kilometers per second in the LSR reference frame. And I think that's actually water in our own atmosphere, because it kind of shifts over the course of days. And if you just plot it without any LSR correction, so topocentric reference frame, so with respect to us, the observer, then that feature is at 0 kilometers per second. So that means that it's basically moving at the same velocity as us, as the Earth. So it has to be close to or at on the Earth. And I think it's just water vapor in the upper atmosphere that we are seeing here. But anyway, so that was quite interesting to see. So here's an average of all the observations. So this is about a total of about 3 hours of integration time. I got about 1 hour of integration time for each of these days. And you can very clearly see this, this spike at 0 kilometers per second LSR, which matches the LSR velocity of the maser in the reported LSR velocities in the maser database, MaserDB. So that was it for the 1 meter dish, but I also had a whole bunch of data from the 3 meter dish from back in November. So back in November, I did a whole series of drift scans of Messier 31, the Andromeda galaxy at 1420 megahertz in an attempt to map the galaxy. So maybe some of you have already seen a little bit of this because I posted 2 videos about my Andromeda observations on my YouTube channel. So this mapping exercise was kind of inspired by a map that was made by Jean-Jacques Mentoux, F1 EHN. So this was this French amateur radio astronomer who was very active. Unfortunately, he passed away a couple of years ago, but he did some really amazing work with extragalactic hydrogen observations, as probably some of you may know. So he did have a tracking mount, so he could do observations of this galaxy in a grid, and he could integrate each grid point for quite a long time because he could track the galaxy. So I of course can't do that because I don't have a tracking mount. So I'm doing all of my observations in drift scan mode. So I was trying to see if it was possible to do the same sort of mapping that he did, but with drift scans only. So that's what I did. So I did 3 drift scans at each at 5 different declinations spaced 2 degrees apart. So there's a total of 15 drift scans. So you might be a little bit surprised that it would even be possible at all to map out Messier 31 with a 3-meter dish, because Messier 31, the Andromeda galaxy, is about 4 degrees across, and that's smaller than the half-power beam width of a 3-meter dish, which is around 5 degrees. However, despite of this, it's still possible to resolve the galaxy, at least to some extent, and this is because the beam is not evenly illuminated. So you have a maximum sensitivity at the very center of the beam, and then it gradually tapers off towards the edges. So the half-power beam width is where you have like half the sensitivity, essentially. So that means that when you point the dish at one end of the galaxy, so the other end is 4 degrees away, so it's well beyond this 2.5 degree half-power radius, so it's thus much weaker. So this is why we can actually, at least to some extent, resolve features that are smaller than the beam width of the dish, such as Messier 31. So here are 4 sample spectra from this whole series. So at different declinations and right ascensions. So you can see that at the southern end of the galaxy is dominated by sort of a blue shifted peak, and the northern end is more dominated by red emission at much lower blue shift. So this is due to the rotation of the galaxy. So one end is moving, it's essentially rotating towards us, so that's more blue shifted, and the other end is rotated away from us, so that's less blue shifted. So this is of course on top of the velocity that and the Doppler shift that the galaxy as a whole has, which is quite negative already. So it's at minus 300 kilometers per second, which is the center of the spectrum. So what I then did is that I kind of divided the spectrum of the Andromeda galaxy in 3 parts. So I took the sort of the blue shifted peak at, I now see that the velocities here are not correct, but the blue shifted peak is at minus 600 to say minus 400 kilometers per second. Took an average of that, and I color coded that blue. Then the redshifted peak runs from around minus 200 kilometers per second to somewhere between minus 100 and 0 kilometers per second. But unfortunately, between minus 100 and 0 kilometers per second, there's also the hydrogen line from the Milky Way. So I excluded that bit, and I only used the part at around minus 100 to minus 200 kilometers per second. And then I also took the sort of plateau feature in between the blue shifted and red shifted ends, and I color coded that green. And if you plot this on the map, this is what you get. So you can see that one side of the galaxy is more blue shifted than the other side. So this is again due to the rotation. So that's also what essentially the same thing that Jean-Jacques Mentux showed in his plot of the Andromeda Galaxy. So, well, that's it. And yeah, if there are any questions, please ask.
I have a couple of comments, Edward.
Yeah, go ahead.
Basically, as far as your hardware and your equatorial mount, what you should do is mount a mini guide scope with a camera. They're usually $60 here in the US, probably 50 quid in Europe. And with that and Nina, which I use extensively, you can actually plate solve the direction of where the mount is pointing. Not only that, but you can do precise polar alignment with it, which you need because you don't have a guide scope. If your beam width is only 1 degree, you don't want to drift because after a while you're going to be drifting. So with a guide scope and a camera, you can have Nina plate solve and point accurately to whatever source that you're pointing to. And that's very inexpensive and very easy to do. And not only that, the added benefit is that you can actually polar align that mount precisely, which you're going to need to do.
Well, the thing is, I'm already well aware of the plate solving function of Nina. So I've thought about that, and there's a couple problems with it. So one issue is that, of course, you say it's very easy, but I don't see it as very easy. I don't have a camera at the moment that I can just plug in. So I have to go out and buy one, and they're definitely way more expensive than.
No, the camera you can get
$60.
you can get an SV Bony, SVBONY. They're the ultra cheap cameras for astronomy. They're usually in the $50 range, and basically that and the guide scope, about $100. What is that? 80 quid, 90, and then you got the polar alignment completely accurately done, and you're going to have the plate solving. And it's not expensive.
Yeah, sure. But the polar alignment is not really an issue because I have a mount with a polar scope in it, so it's fairly easy to polar align quite accurately. The pointing using plate solving, it would work fine if you have a perfectly clear sky, and that's a bit of an issue here in the Netherlands. Is that sometimes like you have a clearing or a gap in the clouds, and then clouds roll in, and what are you going to do then? If you're relying on plate solving, I can't fully rely on plate solving because say I have a perfectly clear evening and I think, well, this is going great. And then I start my schedule and by 1 a.m. at night, clouds roll in. So then I can't use plate solving. So how I'm going to solve
But
that.
once you plate solve the first time, as you already know, then the mount is completely synchronized. So you don't need to plate solve again because it's going to be, this is just a recommendation, but.
Yeah, I know. I'm well aware of plate solving. That's what I was trying to say. But there are some issues with it that I see. That's why I don't want to use it yet at the moment. I'm going for something that's simpler and more reliable for now. Maybe at some point in the future I will invest in plate solving because it's just convenient. But for now I'm a bit hesitant to stick a camera on it and fully rely on plate solving, especially here with the weather here.
Thank you, Edward. That's exciting. You're recreating what JJ did with great results. Well done. Thank you. Oh, I hear Al. Al, we're hearing just scratchy audio. Try again. No, we had just feedback. So actually, I'm going to quiet you. I'll let you work on that as you can. Okay. That was, I think, everybody outside the U.S. We're just trying to do time zones here, except, please, Andrew Thornett is coming up, and then I'm just going to work our way down through the alphabet on my participant screen. Andrew, Happy
Yeah,
New
hi.
Year to you.
And you, Ted? Yeah, hope things fine for you guys. And you've recovered from that big meal you went to. Eduard, I got to say, that was absolutely stunning. Those maps compared to what Jason and I were producing and put into the Eastern Western conferences last year using the 20-meter scope. So incredibly motivational, I think. Plus, you're always an excellent speaker, so it's always great listening to you. So thanks very much again. I can't wait to what you're going to produce next month. Wow. I got a couple of very minor things I wanted to just mention, rather than any results today, particularly. What have I got? Sorry. So, firstly, you might want to look at my picture if you can't see it. I don't know. You can actually, if you want to actually see this, you can pin it. If you pin it, it'll make it big for you. Anyway, that is one of the old Newelec Sawbird H1s, and I just pointed out because a very minor point. I ordered one, and as we all know, I've been waiting for a few to come through. And just as a matter of interest, here's the new one that's come out, which, as you notice, has got no different writing, but a different sized a cover, sort of cover on it, and the cover is no longer plastic. It's a metal cover as well. So I don't know if there's any other particular differences. Or it has the power input in there is a USB-C rather than an old style micro USB as well.
Now, Andrew, we think you're doing a magic trick. You got to hold up both of them at the same time.
Okay.
Two-hand presentation.
So old one, new one. I know they don't look very much different from each other, but it's quite a nice package it comes in, about the same price. The other thing that I was going to mention was I have managed to get hold of, Ted, one of the bare bones. Now, so for those who don't know, these devices, I'll hold up again. So again, but just strikes me, in case it's somebody who's new tonight, forgive me if I've just spoken about things that you've got no idea what I'm talking about. So this company called Newelec is in Canada, and it's revolutionized measuring the hydrogen line in the Milky Way. Because it allows everyday amateurs with something around the meter class or even smaller dish to be able to map the Milky Way and look at dark matter and weigh the Milky Way. And the reason this device has made a difference is because to do that, you need an amplifier and a filter, and it's all there in one single package for around the $50 mark. So it's an amazing little bit of kit. You don't need to know any electronics. You just plug it in line with everything else, and it works incredibly well. What I was going to say, so we got that. What I'll say is they do two versions. So there's the version which I showed, which is the one that's got a box around it, and they do another version, or at least they did used to do another version that had no box around it. And you might think, well, what's the advantage of the one without the box? It used to be that it was a bit cheaper, but also within it had a little resistor, and you could switch the resistor in and out and use it for reference samples for sort of I'm going to use the terrible word calibration, although Ted will want to tell me off for saying that because it's not technically calibration, it's a reference sample. So anyway, I managed to get hold of one of those. Newelec at the moment aren't producing them, but I did a little bit of video earlier on just to show you guys. I remember how to actually show how, on here somewhere was a thing to allow me to do that. Oh. Here we are, share. So share my screen. So can you see this picture that's come up, Ted?
Yes, we see a bunch of wires with a red connector in the middle.
Yeah. So this is inside the house earlier on. So I'm not actually detecting hydrogen line here, but just walk people through. So at the bottom, we've got a Newelec Smart T, which is similar to the RTL SDR type of software-defined radios. And then this is one of these bare bones Newelec Sawbird H1s here. I've got just any old aerial stuck on the end of it. And here I've got one of these HID relay boards, HID, which is what you use for switching off things like lights in your house. And Ted's put a parameter into EasyCol and Easy Radio Astronomy that allows you to switch that, switch the relays on there on and off. And then you should be able to see a reference sample clicking in and out on the screen. So I had a go earlier on, and in good Blue Peter fashion, for those who are wondering what I'm talking about, it was a children's program here in the UK. And they used to do projects, and they'd make sure they had one that they made earlier so that things didn't go wrong. So here, this is, if you watch, you can see the trace on the screen, or the plot on the screen is changing. And then if you look on the right-hand side, we've got the center frequency now is listed as the same as the main center reference frequency. The center frequency are listed now as the same as each other because they're not changing. But below that, where it says file sample quantity, and it actually gives you this is the number of the sample that's been taken. And you notice that every other one, it's coming up with an R next to it. Yes, it should be. Put it back a bit. There you are. You can see that R was there a second ago. And it will come up in a second now.
And way up at the top next to the frequency is an R saying that you're using the relay.
Yeah, brilliant. I'll sit next to the center frequency. Yeah. So really, that was all I wanted to say this evening, and to show people that these there are different ways of doing these things. I know there has been some debate in the online mailing list as to whether it's a good idea to do it this way, or whether better off to use other methods to do references. But there are a variety of ways that you can do it. And for anybody who's interested in trying to explore those different options and different choices, if you'd like to have a go at using that parameter, then you can either speak to Ted or speak to myself, and one of us will let you know how to give it a go, but with no promises that it will work well for you, because we're still trying to work it through, aren't we, Ted?
On many levels, exactly. I think I've gotten everybody that's outside the U.S., just so we can get them in time zones and let them get to sleep or get some coffee. So now we start at the top of my alphabetical list. Adrian is first. Then we go to Al, and then Bob, please. Adrian, what's new?
Do not have very much for the astronomy side. I had sort of minor disaster this last week, though. We had these horrendous winds out in Southern California, and one of the big wind gusts must have been like at least 50 miles an hour. So happened to knock over my disc cone antenna, broke off the top element and 3 of the radials. So that's kind of a horrendous thing. I use that basically just for scanning, and so it's not for radio astronomy. But I'm glad I didn't have a loose dish out in the backyard. It would have become a flying saucer or something, probably a couple of blocks down on a neighbor's backyard. So definitely, any ideas of having a semi-portable dish on the backyard is going to require some very secure tie downs, or at least ballast weights to keep it from sailing on when we get these specific storms that have been rolling into California this last week. We're just getting had more rain than probably we've seen in 4 or 5 years. It's just been kind of really pretty incredible. So in any case, that's kind of where I've been at. Trying to make some progress on the radio astronomy. I had a second laptop that had been blown away by Windows 11, and through a lot of struggles and maybe a little bit of social prodding from Andrew, he excuse me, had volunteered to excuse me, try to help me load Windows back on it, and I was able to get Windows 11 back installed on that. So at least I've got the second laptop that'll be useful for logging. So that's kind of where I'm at.
Very good. We appreciate the picture that you have out your backyard, or maybe it's not your backyard. That's actually up in northern California. Is that right? This is the picture when you talk. What we see here. That's the SETI set of antennas. Maybe they got beat up by the wind too. Who knows? In the meantime, thank you, Adrian. Thanks for the update. Good luck with your hardware issues. Al, you're next. Tell us what's going on. Oh, no. All we hear is staticky things. Maybe there's a voice in the background, but we can't hear it. Is there an easy knob, or should I come back to you? Nope, he says no.
Maybe you should log out and then log back in.
That's an option. We'll try you later on, Al. I moved by down in the alphabet, and Bob, N5BRG, is next. Bob, what are you doing? You're always busy.
Well, I'm here. I'm wondering if my audio is coming through okay, because I do hear strong echoes from everyone. I think I'm probably echoing too, it sounds like.
Not bad at all. It's just kind of the room.
Okay.
And even you suggested maybe Zoom is having trouble. So
Yeah.
go ahead. Please continue.
Anyway, I've been soldering components on PC boards that I built and busily getting that done. I'm short a few components which I've ordered, but due to the holidays, the shipping schedules and everything are slipping. So I should receive the rest of the parts that I need tomorrow to finish building boards, and then I can begin the testing process. And hopefully things will go well there, and I can start to show you some results or talk about results. But that's really all I've been up to lately.
Oh my, is that all? Okay, well done, Bob. Working my way, thank you for that. And working my way down, Dennis, you've just arrived, but you're next to tell us what's new.
Okay. Yes, I just arrived because I haven't been getting email notices about the meetings. Finally ended up having to go to the website and read Rich's message that included a login. So here I am. So I'll get that sorted out later. But I haven't been really very active in this realm. And wintertime is probably the time I'm most likely to come in and sit down. The problem is that most of my hobbies are sitting on my tail end, and I'm not sure it's healthy. Anyway, I really enjoy hearing about the others of you who are making progress, and I'd like to get Ezra working for myself and get it downloaded correctly and understand more about the installation. So I'll pursue that next anyway. Thank you very much for including me, and I'll enjoy listening to everyone else. Thanks, Ted. Bye.
Thank you, Dennis. We're all slowly working on all these projects. Bruce is next. NT4RT. What's new in your world, Bruce?
Okay, see if my audio is coming through. Am I here?
We hear you nicely. Go ahead.
Okay, good. Just mention what I've been kind of up to. Well, first, when somebody mentioned wind damage to antennas, I had a story from 20 years ago, but it was kind of a bizarre story that a friend of mine had shown up with all of the metal segments for a 16-foot solid dish as scrap aluminum. All the back structure was missing. So anyway, I got them for the price of scrap aluminum and got them all bolted together in the backyard and was it started out building a wooden structure behind it to support this because all the support structure was missing. And yeah, so I had it bolted together facing up at the sky, and that seemed like a good place to have it to work with. And well, one day it was real windy outside and I heard a loud thump, and I took a look, and back where my antenna was, and it wasn't there. And about 20 feet further down, there's my antenna face down, and all the pieces bolted together. And so that left it in an odd position. I was trying to figure out how to get it at that. And then I had a guy coming by to mow my fields because I have a large amount of field space. So this guy come by with a tractor. Well, apparently he got distracted, backed his tractor into the dish, and then bent the thing of it. So that turned the rest of it to really scrap metal. But anyway, it was a kind of a sad thing because I had one heck of a lot of work in it. I only had $80 in the scrap metal value of the aluminum. But anyway, that's what had happened with mine. But so much for the wind story. I bet a lot of people have wind damage of some sort that's aggravating. But the thing I've been working on lately is noise, as in Gaussian thermal noise, like we might use to calibrate a radio telescope. And I've been poking a lot at the tiny SA Ultra, which I got one a while back. And it's kind of my replacement for my antique 141T spectrum analyzer. A few people may be familiar with that I had been using. And trying to establish such things as, well, what's the noise bandwidth to it? A response of any device to noise is different than it is to just a carrier. You have your noise bandwidth of filters, you have detectors, response to noise, whatever. So anyway, that's what my current study is, trying to get some handle on that. I think I've got the noise bandwidth thing down. Probably have something to publish in the journal pretty soon on what the noise bandwidth of it is. But without knowing the absolute sensitivity of the detector into noise versus single frequency carrier it's calibrated out, it leaves kind of a bit of a mess here. So anyway, I am working away on that because for some reason or other I've went down the Alice in Wonderland rabbit hole of noise. So that's about what's up for here now. Go ahead.
Thank you, Bruce. The list of stories, amazing. We also have Pablo next, and then Rich. But first, let's test Al. Al, is your audio improved? Give it a try. We are hearing the same problem. We kind of hear a staticky. Maybe there's someone talking in the background, but no words. Thanks for signing out and coming back in. I have Pablo next with Papa. Go ahead.
Yeah, I love Al's transmission. Sounds like from outer space. Sounds like an alien language of some kind. Anyway, right now I have two operational radio telescopes, one 2.1 meter at 1420, and then the Discovery dish, and then I have a foldable one that it's totally unfolded, and I'm waiting to put it online. So I'm doing that, and then I'm going to be working with Ezra and trying to start mapping again, and see if I can use artificial intelligence to meld or stack all three data points and see if I can come up with something with it. Also, I've been doing a lot of, I have two roll-off roof observatories, one 14-inch telescope, the other 8-inch. So I've been observing 3i Atlas and reporting to the Minor Planet Center. And I have a video of that, and then a comment to make, and then I have a request. Can I share?
Of course, please. Go ahead.
Okay, this is my observation, a video of my observation of 3i Atlas with the Tycho tracker software, which reports to the Minor Planet Center directly. And what's important about that, and what it's relatable to radio telescopes, is that Green Bank actually did a radio telescope study, observation, on the 1 to 12 gigahertz band to see if they could find any transmissions other than natural emanations coming from the interstellar 3I atlas, and they couldn't find anything, and they were pretty sensitive, and targeted to see if they could find any extraneous transmissions, telemetry, sending telemetry to Krypton or whatever, but unfortunately they couldn't find that. So this was done by the Green Bank Observatory at the behest of Berkeley, and so they couldn't find anything at all. And then let me stop to share here. And then I've been shanghaied to do a presentation, basic presentation on radio telescopes. And okay, I'm a QRQ, that is high-speed telegraphy instructor for the Long Island CW Club. And they usually have all kinds of technical presentations. So I've been tasked to do 2 one-hour presentations. There's no pay. And so I'm planning on plugging SARA a lot, because these are all ham radio operators. So maybe Rich or you, Ted, can send me some information, maybe if you already have some slides or anything with SARA on it, I'd appreciate it. I already made presentations, basic presentations, to other ham radio groups, but since I've been shanghaied, I got to do it again this April. So that's about all I have right now. And the Discovery dishes are working great. I also had the new Elec and the switch for the dark or the calibration file with this switch here. But now I'm using the Discovery dish setup attached to my 2.1 meter and the Discovery dish. I'm talking about the LNAs, and they work fantastic, and they've been going on. And I live in Southern California. The weather has been horrendous for us, very windy, but since my dishes are well attached to the ground, I haven't had any mechanical problems. That's about it.
Pablo, I have a question for you. Since you use AIs quite a bit, I recently ran into a problem. I kind of use just the cheap Copilot AI, but it's given me some pretty decent sort of responses over a period of time. And just recently, I was trying to design some radio frequency circuits, and it refused to give me any schematics or any parts numbers or anything for potential. It says it cannot generate any circuit diagrams or anything for anything that emits radio frequencies. That's
well,
outside.
I can't speak for Copilot, but if you let me share again, let's do a little exercise. Do I have time for this, Ted?
Of course. We're only
Okay.
halfway through this thing.
Okay, so I use ChatGPT paid because I use it for astronomy, I use it for ham radio, I use it to fix stuff. I can even talk to it, and I'm going to show you in a second. I also did an AI presentation for these for this ham radio. So let's say you want radio telescopes. Let's see if we can find the radio telescope. Okay, we got Radio Astronomer GPT, Radioscope Writer, someone by Sergio Mora. I don't know who he is, but let's see what it can do. But what is the question again?
Well, the main problem was that I was trying to actually design a very low power radio, essentially a QRP transmitter. And I was trying to use some old technology here, using an
this is ham radio. We're not talking about radio telescope.
Yeah, we're not talking radio telescope. This is
Okay,
just
so let me
just
go to the ham radio chat then.
have it design a transmitter circuit and or a schematic and to give you a list of say parts numbers and see what it does, because like I said, the co-pilot just refused to do it. It says it
Okay,
cannot.
you got to be specific with the prompts. What exactly do you want to design?
Okay, I can give you very specifics. Okay, I wanted to use a dual triode 6J6 vacuum tube as a QRP transmitter at 6 meters. And so it's a dual triode. Yeah,
dual triode.
It's an old vacuum tube.
I know vacuum tubes a lot.
6J6. Okay, is the vacuum tube
Okay.
number on that. So again, dual triode. So one half of it would be the oscillator, and then the second half, the other triode, would just be a cathode follower or something. And so it'd just be a little QRP transmitters for 6 meters. And so I just asked her, well, design a schematic for me and give me some part numbers, and it just refused. It says it cannot.
Well, let's ask Hal 9000, see what he can do.
Yeah, there we go. I'm just curious if it's now a general AI thing.
Chad,
just co-pilot.
I want to design a dual triode 6JC, one half oscillator, one half cathode QRP transmitter for 6 meters. Can you do that?
And the 6J6, 6 or J6.
Oh, wait a minute. Let me stop the share here for a second, because when I shared, I did not share the audio. Hold on a second. Okay, share sound. Okay, let's go again.
No worries at all. Take your time to get everything set up just how you need.
Okay, this is what I need. Once again, I need to design a dual triode based on the 6J6 vacuum tube. One half of it as an oscillator, one half of it as a cathode follower. It's a QRP transmitter for 6 meters. Can you come up with some designs?
Absolutely. Let's dive into that. So if we're talking about a 6J6, that's a neat little dual triode that was pretty commonly used back in the day. It's definitely doable to run one triode section as your oscillator and the other as a cathode follower to buffer and drive a little bit of output for 6 meters. Now, in terms of design, you'd be looking at setting up one half of that 6J6 as a crystal-controlled oscillator or even a simple LC oscillator. Then the other half would act as a cathode follower to provide a nice low-impedance output, so you can feed that into a little matching network and then into your antenna. For 6 meters, since we're talking about roughly the 50 megahertz range, you will need to make sure that your coil and capacitor values in the oscillator are tuned right into that band. And definitely keep in mind that
I don't need the explanation right now. What I want you to do is I want you to come up with a diagram and a one-page explanation. Can you do that?
Absolutely. I can put that together for you. So what I'll do is I'll generate a quick diagram of the 6J6 base transmitter setup, and then I'll give you a concise one-page explanation to go with it. Let me go ahead and get that diagram for you first.
Okay, great.
Make that a parts list. But it looks like it's going a lot further, because I can get general discussions out of it. I just couldn't get it to do an actual schematic or assembly instructions or parts.
Okay, yeah, I was talking to her, but I stopped her. But using ChatGPT 5, I don't know about Copilot, but you shouldn't have any problems.
Okay,
let me say that
enough.
I use the same thing Pablo's using, and I've been able to do things like you're asking for with it, no problem. And I've even had it generate KiCad schematic files for me and PC board layout stuff. I usually have to make changes and keep telling it things that it did wrong and tweaking it, but you can get down the road with it pretty well.
Yeah, because it hallucinates once in a while, so you got to make sure that it's accurate, the response. But once again, if you want to do going back to radio astronomy.
Okay, well, that was a good explanation. I guess I just have to change AIs, change from Copilot to chat.
Yeah, I'm not endorsing anything. I'm just telling you what I know, because I use ChatGPT and I pay the $20 a month because I use it for all kinds of things. But for the rest of you, radio telescope. Radio astronomy. Okay. It did work before. I don't know. Okay. I use this one here, the Cosmic Gigahertz Decoder, expert in radio astronomy. So you can ask any questions, have design any circuits, calculate the focal point of a dish in a nanosecond just by inputting the measurements, any problems that you have. So yeah, we're at the beginning of AI, and of course it's going to hallucinate a lot. So you got to make sure that you always check the results. But I use it for everyday problems that I may have with anything, ham radio, astronomy, medicals, legal, anything else. And I found it to be 99% accurate. A couple of times it hallucinates. But you can find stuff on radio astronomy, design circuits, ask for solutions, ideas, premises. So it's extremely useful. Anyway, sorry about that.
Okay, well, thanks a lot. Appreciate the demo.
I have a
I'll have to
question.
check into it.
Yeah.
Hello.
Yes, Robert.
So Pablo, I've just received a feed from NASA about the Atlas meteorite. It's a high resolution image of it from the James Webb. Have you received that one?
Yeah, I've seen it. It has normal. Basically, what they found is they have normal asteroid-like emanations, meaning that there's nothing. That they had a coma. It had outgassing, which is consistent with a standard comet, albeit it's not from the solar system. It's interstellar, but there was nothing. Unfortunately, there was nothing artificial that they could detect either through radio astronomy, visually, spectroscopy, or in any other possible way. But it's still interesting to see a piece of material from another solar system.
That's okay. And the second thing is I'm receiving feeds from Santa Barbara, California, that 101 is closed off between LA and San Francisco due to a landslide.
Yeah, that's
how bad the rain is.
Yeah, it's that song, "It Never Rains in Southern California," is a lie.
True.
We're all turning into frogs down here.
Yikes, so much news. Pablo, thank you much for the new technology demonstration. That's exciting.
You're welcome.
We're working our way down that list, and I think we got everybody outside the U.S., demonstrations and presentations, except, well, actually, no, Al has come and gone. And Rich, are you really there?
I think I am. Oh, I hear that. Just some announcements. Western Conference will be Zoom only. We could not get the Owens Valley venue. They're working on a contract, and it was right. All the presentations for the contract are right in the March timeframe, and they couldn't commit. So we're going to have it full Zoom on 21 March, which is a Saturday. So we are looking for Ken Redcap and I are looking for papers, presentations to fill up the Saturday the 21st. Also, for Dennis, I did find why you didn't get an email. We're shifting to a recategorizing the memberships by instead of we just had it we did it originally by 2025 2026, so we really could not give you credit for applying in June 2025 for an entire year. We just give you that what's left of 2025, but we shifted, and during that shift Dennis got in on the shift, but I had not caught up on the sorting to allow it to sort Dennis's new, number. So we'll fix that, and you'll get on the rest of the emails. So I did find the root cause of that, Dennis, and hopefully that won't happen again. Okay. Yeah, thanks everybody. This was a really excellent RTOP today. Go ahead, Ted. Anything else?
I think we've covered everybody. Al keeps coming and going, but we couldn't get his audio. We wish him well. And as far as I'm working, I'm just slowly in this cold weather working on software, trying to put in having Ezra be able to support more hardware devices. One technique is through SOAPy drivers, and that's been fairly successful. But another way is simply using GNU Radio, and it may not be a perfect match, or it might be pretty good. I haven't quite decided. But I also consider it a more complex environment to install on your system, and so it's only for those who are brave at this point. But progress on that thing as well. And then even other methods of trying to extract the hydrogen and enhance it. I've got some new methods as well that seem to look promising. So more stuff is coming. Folks are always welcome to contact me on the Ezra webpage, Ezra Radio Astronomy, Easy Radio Astronomy. You will find my web email address down at the bottom. That's the news from me. I make mistakes. Did I miss anybody? Okay, back to Rich. I think we're kind of done.
All right. Thanks, everybody. See you in 2 weeks for Drake's Lounge.